Hello everyone! Today we will explore the solution to a clustering problem using the k-means method. Let's say we have some points on a plane. I know, random points sound quite dull, but I still want to start with this example, and in the future episodes I will show you how to apply this method to a real-world problem. When you look at these points, what happens in your head? Personally, my brain tries to find some structure in this data. It looks something like this. So, our brain tries to somehow organize and identify common features among the objects it sees. This happens automatically, without much effort. I will understand the cluster as a group of objects unified by certain shared properties. In this case, the property is that some points have a certain density and are far from other groups of points. In principle, this is a possible solution to the clustering problem, which our brain provides for free. However, it doesn't always work like that. If there is a lot of data with a complex structure, it will not be easy to quickly find common characteristics just by looking at it. Therefore, let's try to solve this problem through programming. Now let's try to implement the solution as a program that will identify the clusters to which the points belong. I propose to do the following. Let's choose 3 random points from the given set and consider them as corresponding to 3 different clusters. I will display the points belonging to a certain cluster using different colors. So in this case, we have determined the belonging of 3 points to different clusters. Now we need to figure out all the remaining points that are not currently associated with any cluster. To do that, we will take each unlabeled point one by one and determine the nearest point from the 3 fixed at the beginning. After that, we will assign it the label corresponding to the nearest point of 3 chosen ones. For example, in this case, the point belongs to the blue cluster. Next, we will repeat this process for all points. As a result, we will get this kind of clustering for our data. In reality, we have the potential to refine our solution. To achieve this, we will systematically examine the points of each cluster and calculate a new centroid for them. Instead of relying solely on 3 random points chosen initially, we will consider the centroids obtained through the process of averaging the coordinates of various clusters. This is precisely why the method is termed k-means. It involves averaging within each cluster at a specific point in time to derive a new centroid. Subsequently, we will need to iterate through the same steps as before, that is, assigning a label to each point based on its proximity to the nearest centroid. As evident, even by the second iteration, we yield a reasonably good solution to the original problem. This indeed constitutes a description of potential implementation of the k-means method. Now let's proceed to the actual writing of the program. Let's create a separate folder for today's episode. I'll name it naive k-means. Now I'll set up a virtual environment inside this folder like so. python-m venv.\vnfutils. After that, we need to activate the virtual environment. I'll do it by using the command source venvutils bin activate. For Windows system, you need to execute the following command: venvutils scripts activate.bat. Excellent, the virtual environment is activated, and we can proceed to install the necessary libraries. To do so, let's execute the following command: pip install numpy pandas plot9 scikit-learn. Now let's dive straight into our task. Today I will demonstrate the code I used to solve the problem without delving into intricate details. I recommend you to follow along by clicking the link provided in the description of this episode and replicate all the steps outlined in the text version of this episode. If you encounter any difficulties, feel free to ask questions in the comment sections of this episode. I will create a file named kmeans.py. To start, let's import all the necessary libraries. After that, let's generate the points we want to cluster. Our data consists of table with coordinates of points. Now let's simply visualize how our original data looks. Let's run our program and make sure everything works correctly. I will use the plot9 package for data visualization. Let's create a new column in our table to store the cluster label to which each point belongs. Initially, let's assign all points to cluster 0. Later on, we will reassign the cluster label for each point as demonstrated earlier in the video. All that's left is to bring to life the visualization we saw at the beginning. So we need to select 3 random points from among all. Let's create a function that returns k random indices, where k is a number of clusters. It will take the number of points and the number of clusters as arguments. Now let's use these indices to assign cluster labels to 3 points from our data. I'll use the labels 1, 2 and 3 as strings. Let's visualize our current data. Now let's create a function that will find the nearest cluster center for each point. We will call this function getCluster, which takes the coordinates of the points and the current centroids as arguments. Inside the function, I will utilize a property of NumPy arrays called broadcasting. This property allows us to avoid unnecessary loops and compute the distance from each point to the specified centroids. I'll provide the link in text version of this episode for you to delve into the details of how this function works. As a result of function execution, we determine the index of the nearest center and assign labels to the points accordingly. Let's use the function and update the cluster labels in our data frame. And now let's visualize again the updated version of the picture with our data. Next, we need to determine the mean position of coordinates for each cluster. Let's create an addition function that takes our data frame as input and computes the center for each cluster. After that, we can display the computed mean centers for our current clustering. All that's left is to repeat the above steps until the cluster labels match for 2 consecutive iterations. Let's encapsulate this in an infinite while loop. And finally, as a result, we obtain the following outcome. I understand that some parts of the code may not be super obvious, but I am always here to help you understand the details. However, one of the good ways to learn programming is through the process of analyzing someone else's code. In any case, just let me know if you need any hints regarding today's episode. Just drop it in the comment section. That's all for today. Next time we will look at an example of using clustering for real data rather than synthetic data. I know, random points might not be the most thrilling example, but let's aim for something more exciting next time. Until next time, take care, my friend.